First of all, thank you for joining this session. And my name is Hyomin Kim, and you can call me Derek. Derek is my English name. I was originally from South Korea. And I was actively contribute to the South Korean GDG community before, but I moved here, Canada, about 4 months ago. So I have a chance to present this kind of substance. So yeah, so today I'm gonna share how to build cost-optimized network architecture in multi-cloud. So in the AI era, and yeah, and also I work as organizer said, I'm working for a US-based company named as Tetrate, and I'm working as a SRE. So if you have any questions about SRE or cloud, other things, let me know anytime. And yeah, let's start. Here's the agenda for today, and yeah, let's dive in. Let's dive into the first topic. First one is multi-cloud scenario without VPN. Today is, I think it is a AI era. So becoming AI era means many workloads can be moved to other clouds. Like let's say we mainly run our workloads on the AWS before, but let's say we want to use Gemini or ChatGPT, these kind of things, then we should send the data, our data from the AWS to the GCP or Azure to develop some model for AI or machine learning. It means we have to send huge data from AWS or other clouds to GCP or Azure. So I think we also have to consider this data transfer cost as well, because in cloud, cost is so important, and using cloud can be very expensive. So in terms of cost, I'm gonna tell you how to build a cost-optimized network in a multi-cloud. First, let's see multi-cloud scenario. As you can see, typically a VPN or a dedicated line is used for security. In this diagram, EKS and GKE need to communicate using private IPs. So we need to create a VPN. Of course, if there's no VPN or dedicated line between the two clouds, communication must happen via public IPs. However, you probably don't want to necessarily expose your services with public IPs. That's why VPNs or dedicated lines are typically used for security. Today, we're not focusing on the security aspects of VPN. Instead, we will explore how using a VPN can be cost-effective in a multi-cloud. In this scenario, the main workloads on AWS, and while the ML and data analytics workloads are on GCP, because we use GCP many services in this scenario, there's no need for a VPC on GCP. And it's quite common to run your main workloads on AWS first. And later, many companies adopt GCP to handle AI or machine learning workloads because they have very powerful AI and ML services like BigQuery, Vertex AI, and Dataflow. So I think typically startup begin by running their services on AWS, be honest, which is widely used as a foundational cloud platform. As they scale and require advanced AI, machine learning, or data analytics capabilities, they often add GCP to their infrastructure due to its strong offerings in these areas. So this makes such multi-cloud setup a frequent choice. Anyway, some of you might already know, but to understand today's presentation, it's important to note that GCP managed services such as BigQuery, PubSub, and GCS use the *googleapis.com domain. So BigQuery is a bigquery.googleapis.com, and PubSub is pubsub.googleapis.com, etc. And since these domains belong to the Google managed services and are publicly accessible, they use public IPs. So this domain will use public IP because these are all managed services of GCP. Like this, if you ns lookup pubsub.googleapis, you can get public IPs. Because public IPs are used, you can send data from AWS to GCP managed services over the internet without needing a VPN. But I want to say, if you don't need it, VPN or dedicated line can be a good option. Even if you don't need it, VPN or dedicated line can be a good option in terms of costs. So I'm going to talk about why do we need VPN for the cost-optimized multi-cloud architecture. As I say, let's say main workloads run on AWS and data analytics workloads are on GCP because BigQuery is a public managed service of Google. It has public IPs. And let's assume we transfer a lot of data such as log data, database dumps, and user event data from AWS to GCP BigQuery. So this is what the traffic flow looks like. Data from AWS passes through NAT gateway, then travels over the internet to reach GCP managed services. Let's focus on the AWS NAT gateway pricing. For AWS NAT gateway in the CA Central 1 region, Canada region, the cost is 0.05 per gigabyte of data processed. And in the CA Central 1 region, the cost for internet outbound traffic is $0.09 per gigabyte. It means 0.05 for NAT data processing cost and 0.09 for outbound data transfer cost. But we can save the NAT data processing cost. How we can save the data, NAT data processing cost? Let's say if there are VPN connections between AWS and GCP, with VPN connections, the traffic flow shifts from the NAT gateway to the trans gateway, and traffic is transferred to BigQuery through GCP Cloud Router. The trans gateway, so it means we will change the traffic. Not through the, we will change the traffic through the NAT gateway to the transit gateway. So the transit gateway data processing cost is $0.02 per gigabyte in, sorry, it should be the Canada region. And while VPN also use encrypted communication, they use internet, so outbound data transfer costs are same. So it means, as you can see in this diagram, the transit gateway's data processing fee is more than 3 times cheaper than that of the NAT gateway. As you can see, it was originally cost $0.09 and $0.05, but this outbound traffic is same, but this transit gateway data transfer fee is about almost 3 times lower. So we can save the cost of just adopting the VPN. Let's say you might think, oh, is it good enough to adopt a VPN just for that $0.0 for saving this kind of data cost? But let's say we transfer about 20,000 gigabytes per day from AWS to GCP on a daily basis. I think someone think, oh, it is an unusual case, but actually at my previous company, we sent a lot of data from AWS to GCP to just use manage GCP AI services. So I think it's a very plausible scenario. So without VPN, using the NOT gateway, data processing costs $1,000 per day, combined with a outbound transfer cost about 1,800, totaling $2,800 per day, or $84,000 per month. Without VPN, using the Trans Gateway, data processing drops to $400 per day, and the outbound transfer remains the same at $1,800, bringing the total to $2,200 per day, or $66,000 per month. So in summary, if you're transferring 20,000 gigabyte per day, you can save $600 per day, or $18,000 per month. I think it's quite a huge cost saving. So as mentioned earlier, if you're frequently sending large amounts of data to other clouds over the internet, I highly recommend using a VPN. But connecting AWS and GCP via VPN alone doesn't allow private access to GCP managed services. To make it possible to communicate with GCP managed services, you need Private Service Connect and DNS setting. And Private Service Connect, so it means we should configure asterisk.googleaps.com to return a Private Service Connect IP. It's a kind of internal IP, not a public IP, instead of typical public IPs. After we make a Private Service Connect and DNS setting, a domain query for asterisk.googleapis.com will resort to the Private Service Connect IP. And then AWS server can communicate with GCP managed services with Private Service Connect IP. And yeah, what's the Private Service Connect? Let's learn about this Private Service Connect on GCP. And GCP, in many cases in GCP, they use Private Service Connect when trying to make a connection between other services, other SaaS service, other third-party service, or other cloud service. We use Private Service Connect much. So if you learn this service, then it will be helpful, I think, later. And GCP Private Service Connect allows you to access multiple Google APIs or Google services through a single assigned IP. This setup enables the use of internal IPs to access Google APIs, significantly enhancing security. Additionally, it supports services like the GK control plane and various third-party services, ensuring a secure and streamlined connection. For those familiar with AWS, GCP Private Service Connect is similar to AWS endpoints. That just like you can connect to AWS managed services like DynamoDB or SSM using a user-assigned IP. Private Service Connect allows similar functionality for Google services. It provides a dedicated entry point, enhancing security and simplicity. So yeah, we can apply to the Google APIs as well by assigning a Private Service Connect IP for Google APIs and adjusting the DNS setting for asterisk.googleapis.com. Requests to these services no longer use public IPs. Instead, they are routed through the Private Service Connect IP, ensuring a secure and private connection to Google managed services like GCS, Bigtable, and Spanner. As you can see, after I assign this Private Service Connect IP, pops up .googleapis.com returns user-assigned IP, not public IPs. Yes, and then let's talk about the let's talk about how to build this. To establish VPN between AWS and GCP, we should create Trans Gateway and Cloud Router. And then we have to set up site-to-site VPN and Cloud VPN. There are plenty of documents on setting up VPNs in AWS and GCP, so I won't go into detail today. However, I've created a blog post on this topic. If you're interested, please scan the QR code displayed here. And then let's learn how to make GCP Private Service Connect. First, you go to Network Services in Google Cloud and select Private Service Connect and click the Connect endpoint. Also, you have to select all Google Cloud APIs. This means all Google managed services will communicate using the assigned internal IP, not a public IP. Then select your VPC and assign internal IP for the Private Service Connect. Then you can see the GCP Private Service Connect setup details here. It shows the assigned IP addresses like 10.10.10.20 and confirms that all Google Cloud APIs are selected. This ensures all managed services communication through the specified IP. So, and you also need DNS settings for GCP as well. To set up DNS on GCP, you need to create a DNS zone for googleapis.com. First, select private zone type and DNS name should be googleapis.com. Then select default and lastly, add your VPC. And you also need to create a record for the googleapis.com domain with the CNAME pointing to the assigned IP, ensuring requests are routed correctly to the Private Service Connect, like this screen. After setting the Private Service Connect and configuring DNS for stars.googleapis.com, resources in GCP in the GCP VPC, such as GKE and VMs, can access GCP managed services using internal IPs. This eliminates the need for the public IPs. Since our ultimate goal is to enable multi-cloud communication from AWS to GCP managed service, we need to advertise the Private Service Connect. So we just created to AWS through the GCP Cloud Router. To advertise it, you should go to Cloud Router page in Network Connectivity and make a custom route for Private Service Connect IP. So, because we use 10.10.10.20, so just input this IP range in the Cloud Router to advertise this IP range to the AWS. There are also steps to take on AWS side. First, in the routing table of the AWS subnet that needs to communicate with GCP, you should configure a static route for the Private Service Connect IP to the transit gateway. You just need to create a static route for the Private Service Connect IP in the routing table. It's simply a matter of adding one line to the routing table, so it shouldn't be too difficult. Lastly, you will also need to configure DNS setting on the AWS side, just like we set up the DNS record in GCP Cloud DNS to return the Private Service Connect IP for the googleapis.com domain. You will need to create a same private DNS zone in a Route 53 and add the corresponding record like this. If you don't want to create duplicate DNS zones for googleapis.com in the both AWS and GCP, you can forward domain queries from AWS to GCP Cloud DNS. Of course, as you can see, the architecture can become slightly complex, but DNS forwarding remains a good solution. In this setup, AWS Route 53 forwards domain queries for the googleapis.com to GCP Cloud DNS. Then the AWS VM or AWS EKS begins communicating with the Private Service Connect IP obtained from GCP Cloud DNS, not a AWS Route 53, allowing access to managed services like BigQuery and PubSub. But it seems a little bit tricky. So if you want to know how to make this setup as well, so just you can scan as well from here. And lastly, I'd like to briefly introduce GCP cross-cloud interconnect as well. By utilizing this service, at my previous company has been able to significantly reduce network costs without additional operational efforts. And I want to recommend that you consider using a dedicated line like AWS Direct Connect and GCP Cloud Interconnect for large data transfers, such as 20 terabyte per day. Because quite simply, the transfer out costs for a dedicated line are much cheaper than the internet transfer out cost. So what is GCP cross-cloud interconnect? If you've used dedicated lines, you will likely familiar with AWS Direct Connect or GCP Cloud Interconnect. However, GCP Cross-Cloud Interconnect is a more recent service, so some of you might not be as familiar with it yet. As someone who has used it, let me briefly explain what GCP Cross-Cloud Interconnect is. Before cross-cloud interconnect, creating a private connection between AWS and GCP without VPNs or required placing your custom router in a colocation facility. You have to connect dedicated lines to this router to establish the private connection between AWS and GCP, but it is complex and there were several pain points with this approach. First one is operational complexity. Managing custom routers at co-location facility increased complexity. And the second one is skilled network engineers were needed for management and troubleshooting. Third one is coordinating with co-location providers when managing contracts added significant administrative overhead. So when we just make a private connection between the between clouds, we just adopt just VPN. But cross-cloud interconnect can serve these pain points. With cross-cloud interconnect, you no longer need to deploy your own hardware or coordinate with third-party providers, because Google takes care of these takes for you. So let's compare our previous use case by looking at both VPN and cross-cloud interconnect. VPNs incur internet outbound costs, so the outbound data transfer cost is about $0.09. But Direct Connect, however, is about $0.035 per gigabyte, nearly 3 times less. Using dedicated lines involves additional port cost charges hourly by each provider, assuming 2 parts for high availability. So because one line, let's say one line is down, then the other line should be up. So we're gonna use 2 dedicated line for the high availability. Then AWS charges just $4.5 per hour, while GCP charges $11.2 per hour. The higher cost for GCP is because cross-cloud interconnect performs the role of a custom router in a co-location facility, as I said, like this part, Google managed it. So it is a little bit higher, much higher than AWS port fee. So, however, if you're transferring a large amount of data from AWS to GCP, as in this use case, using cross-cloud interconnect is much more cost-effective. assuming you transfer about 20 terabyte of data from AWS to GCP daily, using cross-cloud interconnect instead of VPN can save approximately $720 per day, or about $21,000 per month. It's a huge cost saving as well. So, and the concepts I've explained apply similarly when sending data from GCP to AWS. So from a cost perspective, cost-wise, I highly recommend setting up at least a VPN for your multi-cloud network configuration. And if you're handling large data transfers, consider implementing a dedicated line as well. With that, I will conclude my presentation. And yeah, thank you for joining my session. And yeah, see you. And yeah, thank you for joining my session. And if you have any questions, and just let me know through messages. And if you have any additional questions, you can just message to me through LinkedIn and Medium, other things, and anytime. Yeah.